Welcome to conditionals. Conditionals are very important in a program because they allow us to make decisions with our programs. And if you can imagine, the computer has to make decisions all the time about what should I do when a user presses this button, or what happens when this hits a wall, or what happens when the object explodes. So it has to make decisions all the time. And these decisions are called conditionals. Now, there's lots of examples we can use in our own life. Like, if you eat your vegetables, then maybe you'll get dessert. Maybe if you behave and you do all your homework, you'll get chance on the computer. Maybe if you do all your homework this week, you get video time on the weekend. So if you do something, then you get something, right? It's commonly, we used to call it an if-then statement, but now we just call them if statements or if-else statements. So they are statements that run only under certain conditions. So we think of them sort of as like this: either this didn't happen or it did happen. Yes or no, true or false. So if it's true, we look at this example right here, the condition is if it's true. So if you ate your vegetables, then this happens. If not, then this happens. That would be the else. That's one way we could look at it. Or nothing happens. Let's go to the next one. Usually an if statement, such as if you eat your vegetables, you get your dessert. That's a pretty simple one. The condition is if it's true, eat the vegetables, you get the equals the reward. Or if it's not true, you get no reward. I'm sure you've encountered lots of these things in your lives. We also call these, and I know this is a big word, it's called a Boolean statement. And I know I'm going to use this a lot in class as we get into programming, and we'll see this again if we get beyond Scratch, but it's a true-false condition. So it's any question that's can only be true or it can be false. It's called a Boolean. So if the question is it red? It either is red or it isn't red. It's either true, it's red, or false, it's not red. That's called a Boolean statement. So it's anything that can only be true or false. You can say, oh, that's a Boolean statement. We can think of lots of examples for this. Colors are a common example I use, but either you did get 100 on the test or you didn't get 100 on the test. You did go to school or you didn't go to school. Now, those are all true-false statements. Okay, and then we can also use an else, and this is something we can introduce, not just the true-false statement, but if it's not true, we can have another condition that falls below it. Sometimes we want another condition. For example, if I write 7, clap. Else, say, aww. So if I clap 7 times, or if I write 7, you would clap. Otherwise, you'd say, aw. So I could write 7 on the board, and you would clap. See, it's two conditions, but each condition has a result. You either clap, or you say, aw. So that's an else. And we can introduce lots of else's in our programming. We'll talk about that more later. Like if we could add another condition saying, because if is the first condition, else if the first condition isn't true. So, for example, if I write 7, clap, that's the first condition. Else if I write a number less than 7, say, yay. Else, say, aw. So there's 3 possible results from whatever I write on the board. It could be 7, it could be less than 7, or it could be something else. Maybe more than 7, or I don't write anything. That would be the last condition. So the more else's you add to your if statement, the more conditions you can have, and there's really no limit on how many conditions you can have. So each one of these is a separate condition. Now, I'm going to show you some pseudocoding. And pseudocoding is when we practice as programmers, when we're getting ready to write our code, sometimes we jot down notes in pseudocode. So when because we don't write it exactly how it's going to appear in the program, we just write it how we're thinking it. It's sort of like a rough draft for programmers. So let's say if we played a game, and if the card, and we have, a deck of cards, and there are red cards and there's black cards. If a card is red, when I pick it, when I turn it over, you award your team 1 point. Else, you award the other team 1 point. So do you understand? If it's red, you get a point. If it's not red, if it's black, in this situation, probably could only be black unless we have jokers or something else in the deck, then the other team gets 1 point. Now, the way we'd code that is on the bottom here. If the card, and I'll talk more about this equal sign, but it means equals. If the card color equals red, your points equals your points plus 1. You add 1 to your points. Else, the points of the other team's points gets plus 1 to its point. So it would increase by 1 point. And it would keep score this way. This is how a program keeps score, by adding 1 or incrementing those values. You could, as we talked before, you could add more conditions to your if statement. So not just if your card is red, award your team 1 point. Else, you could have another big else condition. You could put an if in that else condition. This is kind of advanced. If that card is higher than 9, you award the other team 1 point. Else, award your team the same number of points on the card. So that way the other team only gets the points if it's not red and the points are higher than 9. So that's another way we just adding conditions to our game. So that's a brief overview of conditionals. It's more advanced than probably the activities you're going to be doing today, but we will need to get a lot more advanced when we make our game. So this is just a little start to the activities that we'll be doing later on in Scratch. Now I'm going to show you some the examples from the lessons you'll be doing on code.org. Okay, now we have our first conditional. It really comes on the third situation here, so I'm jumping right to the third one. The first two we're just practicing what it would look like without a conditional. So you'll look at the flower that we have to pick up nectar from this time, and you'll see there's no number next to it. It's purple to really hit that home, but there's no number here. Instead, it's a question mark. So the reason for that is we don't know whether or not it has nectar. If we look at the condition here, let's make it a little smaller so we can see it. Purple flowers may either have 1 or 0 nectar, but you don't know which one. Be careful not to collect nectar from a purple flower if it doesn't have any. So check if the nectar is equal to 1 by using the if block. So, and if we think of that and how we just saw it, if it has nectar, or if the nectar equals 1, then we should what? Get the nectar, right? You could say that differently. You could say, if it's greater than 0, right? That would work in this situation, right? Because if it's greater than 0, if it's more than 0, you would also get the nectar. But you could also say, if it's equal to 1, we should also get the nectar. We couldn't say if it's equal to 0, get the nectar, because then it would only get the nectar if it didn't have any nectar, and that doesn't make any sense, right? So let's change this back to 1. So if the nectar equals 1, so when you get here, if the nectar equals 1, then get the nectar. So what is it going to do if it's not 1? It will not get the nectar. That's the we don't put it as an else because it would automatically not do that. It wouldn't do anything. So if we took this out, it would just move forward 3 times and not do anything, which is the same it would do if it was not 1. If we change this to equals 2, get the nectar, it probably wouldn't get it either because we know that it's either going to be 1 or 0. So let's try it. I'm going to run. when it got there, it found one nectar, so it got the nectar. And if we did that without, if we go back to it just for a second, sorry. I think when we show this, yeah, you'll see when it moved, it only had one nectar. See, it shows the one after we start moving. So if we go to the next one, start over. So we're in the same situation, except now we're one away from the flower, so I'll do a move forward. But then when we get to the flower, we'll have to check for the same thing. We see if there is either one nectar or 0 nectars. So the way we can check that is, again, like I showed you, it could be equal to 1. We could also put greater than 0. We could put, once we get into other conditions, we could put other things, but I think that's all we can put for now. So if nectar equals 1, do what? We should not make honey. We need to get the nectar. Does that make sense? As you move along, these will get a little more complicated. You'll have to do things like make honey, but this is a lot simpler than what I was probably just showing you in the presentation. As we move along in this class, we will get into much more complicated if statements, if you want to, and you probably will for your games. So it's a little that was a little preview also to what you'll need to learn. Good luck on this, and please let me know if you have any questions.